Today we will be learning about Ohm's law. In this presentation, you'll learn about electrical resistance, short circuits, Ohm's law, a guess method for problem solving, and we will do some practice questions. So, what is electrical resistance? As you recall, it is the ability to oppose or obstruct the flow of electrons. The symbol we use is R, and the unit of measure is ohms. This is denoted by the symbol omega. So when electrons flow through a resistor, it causes a loss of electrical potential known as a voltage drop. So when you see a heating element on a stovetop, the electrons are flowing through this conductor or resistor, and as they are being obstructed, the flow of electrons are being obstructed, some heat is produced due to the potential difference drop. Now on to short circuits. You might have heard of something short-circuiting. What does that mean? Electrons are, we could say, inherently lazy, and they will always want to take the path of least resistance. So in a circuit, if electrons are allowed to flow through the circuit without going through the load, so if they were to go down this way without going through the light bulb, then they would return back to the cell without losing any voltage. So this would result in the cell becoming hot, and that could result in a fire. So what is Ohm's law? Ohm's law states that the potential difference between 2 points on a conductor is proportional or directly related to the electric current flowing through the conductor. We use the formula V equals I times R, which is used to show the relationship of current, voltage, and resistance. Recall that V stands for potential difference or voltage drop, measured in volts, I is the electric current measured in amps, and R is the electrical resistance measured in ohms. So we can use the triangle. Recall we used this type of triangle when we did density, and we use the triangle so we can rearrange the equations easily. So I can drop in our variables, V, I, and R, and I can solve for each of these variables by rearranging the equation. So if I wanted to solve for current, it would be voltage over resistance. So I can cover up, imagine if I cover up this I, I'm left with V over R. Now if I want to solve resistance, similarly, I can do V over I. If I cover up the R, I'm left with V over I. And if the two variables are beside each other, then it's V equals I times R. So let's see if we can do some practice problems. Don't forget to use our formulas that we just derived using the triangle. So if you wanted to solve for current, see if you can do that. You can pause the video here and see if you can solve for current. Okay, so if you pause the video and you're back, let's see how we would solve for current. We would take I equals V over R. We know that V is 30 and R is 25. So if you divide 30 divided by 25, you should have gotten 1.2 amps. The resistance, similarly, if we were going to solve for resistance, if we cover up that R, we need to do V over I. So we would do 30 divided by 2.5, and you should have gotten 12 ohms. Lastly, in this situation, we need to solve for voltage. So voltage is I times R, and if you multiply 72, or rather 0.25 times 72, you should get 18 volts. So let's use that to now solve some problems. We're going to use the guess method. Now some of you might recall we use the GRASS method, which is what the textbook uses. It's essentially the same thing, so you can use either way. What does guess stand for? Given, which you write down the information that is provided. Unknown, you need to write down the information or what it is that you need to find. The equation, you will write down the equation you will use to solve that question. The solution, substitute and solve your solution. And don't forget your final written statement, which is in the form of a therefore statement. So let's try this problem together. So the question is, what is the voltage drop across the tungsten filament in a 100-watt light bulb? The resistance of the filament is 144 ohms and a current of 0.833 amps is flowing through it. You need to round to the nearest hundredth. So let's recall that given is that the resistance is 144 ohms and the current is 0.833 amps. What are we trying to find? Well, it says, what is the voltage drop? So we are trying to find V, the voltage drop. How will we find it? We need to figure out our equation. We're trying to find the voltage drop, so these two variables are beside each other. We're going to multiply. So the equation is V equals R times I. Now you can substitute in your values. You can put in the 144 ohms for the R and the 0.833 amps for I, and you will solve that to be 119.952 volts. Now remember, it said to round to the nearest hundredths, so we're going to say 119.95 volts. Don't forget your final statement. Therefore, the voltage drop of the light bulb will be 119.95 volts. Here's another question for you. Feel free to pause the video again and try it. Okay, so how would we do this? Again, this time we are given the voltage and the resistance, and we're trying to find the current. The equation is I equals V over R. We substitute in our values, and then we will get our final therefore statement. Therefore, the current through the resistor is 0.33 amps. If you made it this far and you understood the video, you're in a great place. Let's try some homework questions. Review the sample problems, numbers 1 to 3, on page 568 to 569 of your textbook, and then try to complete the questions 4 to 8 on page 570. If you need to repeat this video, feel free to do so. Bye for now.